Hey everybody, this is problem number 4 from chapter 8's free response questions. So I'm going to go through it real quick, just some problem solving strategies. So this is giving us an initial velocity, 8 in the I hat direction. Now if you don't remember, I hat is the x world and j hat is the y world. It's just like alphabetical order there, essentially. And what this tells me is that I've got an initial velocity in the x world, and I don't have an initial velocity in the y world. I am also given this information about the force. Now notice it says variable force. So what that tells me, if it's a variable force, is that my acceleration is non-constant. All right, acceleration non-constant. Now that's important because all of the kinematic equations we have for acceleration are for constant acceleration. That means that we can't use those here. So let's think about another way that we can get acceleration. We're given this force equation, and then we're also given a mass. So we can relate acceleration as force divided by mass. So let's just get an expression for that real quick. So this would become negative 2.0 t in the I hat plus 4.0 t squared in the j hat divided by 2.0 kilograms. So what I get is that my acceleration is equal to negative 1.0 t I hat plus 2.0 t squared j hat. Now if you want to rewrite this in each direction, that's fine. So acceleration in the x is negative 1.0 t, and acceleration in the y is 2.0 t squared. Whichever one of those is easier for you to see. So that's step 1. Step 2, we want to determine velocity from acceleration. So how do we get velocity from acceleration? Well, velocity is just equal to the integral of acceleration with respect to time. Now, one addition to this is that we need to add on the initial velocity to this. So we're going to get some expression that looks like this. Now, we're going to need to do this in each direction. That's why we needed to get the accelerations in each direction. Now notice, again, acceleration is not constant. So I cannot say v final equals v initial plus acceleration times time because this value is going to be non-constant. All right, so I cannot do that. This is no good. So if we move on, let's start with acceleration in the x. So if I have velocity in the x is equal to initial velocity in the x plus the integral of acceleration in the x dt, I need to think, all right, what interval am I taking this integral over? Because this integral has an initial condition and a final condition. So I need to know what interval I'm taking it over. Well, that's where part A comes in. It says, what is the projectile speed at 2 seconds? So what that tells me is that I'm going to take this integral over the interval 0 to 2 seconds. So let's just plug stuff in. Velocity in the x is equal to initial velocity in the x, which we already said was 8. So this is 8 meters per second plus integral from 0 to 2 of negative 1.0 t dt. Now I take the integral of this, so I get velocity in the x is equal to 8 plus, now negative 1.0 t. So that's going to be 1, that is going to be 1, wait. There we go. 1 divided by 1 plus 1 times, so that's negative 1 divided by 1 plus 1 times t to the 1 plus 1 from 0 to 2. So this becomes 8 plus negative 1 t squared, or negative 1/2 t squared, from 0 to 2. So then I need to evaluate that integral. So it becomes 8 plus, I'm going to have negative 1/2 times 2 squared minus negative 1/2 times 0 squared. So I end up getting velocity in the x is 8 plus negative 2 minus 0. So velocity in the x is going to be equal to 6 meters per second. All right. Now we do the same approach for velocity in the y. So velocity in the y is equal to initial velocity in the y plus the integral from 0 to 2 of the acceleration in the y dt. So this becomes 0, because I have no initial velocity in the y, of the integral 0 to 2 of 4.0, or sorry, that was 2.0 t squared dt. So this becomes, I've got 2 divided by 2 plus 1, t to the 2 plus 1 from 0 to 2. So this becomes 2/3 times 2 cubed minus 2/3 times 0 cubed. So this becomes the velocity in the y is equal to 16/3, which is equal to 5.33 meters per second. All right. So now I've got both of these. But remember, the question is asking me, what is the speed at 2 seconds? So in order to determine speed, well, speed is just the magnitude of the resultant velocity. And in order to determine the magnitude of a resultant vector, I can do Pythagorean theorem. Now, if you need to visualize that, think about it like this. Here's my velocity. Here's the x component of my velocity. Here's the y component of my velocity. We got a right angle there. And so if I want to determine what the magnitude of that side is, the hypotenuse, I need to Pythagorean theorem it. So this becomes 6 squared plus 5.33 squared, square root. And I get that the magnitude of my velocity, or the speed, is equal to about 8 meters per second. All right. So that is the magnitude of my speed at 2 seconds. Now let's move on to part B. At what instant of time is the projectile moving parallel to the y-axis? Okay, parallel to the y-axis. Let's think about what this means. What this means is that this is the point where my velocity in the x equals 0. All right? This is where the x component of my velocity is 0, because at this instant, my motion is all pointed upwards. And here's my y-axis. Here's my x-axis. So I need the location where the velocity vector is pointing straight up or straight down, parallel to the y-axis. All right? So what we end up getting here is we need to take, again, the velocity vector. So velocity in the x is equal to initial velocity in the x plus the integral of the acceleration in the x dt. Now what we need to think about here is, where is this time? All right? So this is where our initial conditions come in. All right? Now before, we were looking for a specific moment in time from 0 to 2. Now the question is, what is the time? So the question is about the time. So we're going to go from 0 to t, because t is what we're looking for here. All right? So we got velocity in the x is equal to initial velocity, which is 8, plus the integral from 0 to t of acceleration in the x. Now, we already solved for the integral of acceleration in the x. It's -1/2 t squared. So this is going to be -1/2 t squared. And I'm evaluating that from 0 to t. So what I end up getting is velocity in the x is equal to 8 plus -1/2 t squared minus -1/2 0 squared. Okay. Now obviously this goes away. So I get that the velocity in the x is equal to 8 minus 1/2 t squared. So I'm going to rewrite that over here. Velocity in the x is equal to 8 minus 1/2 t squared. And now I need to go back to what I'm solving for. I need to know, when does velocity in the x equal 0? So let's set it equal to 0. 0 is equal to 8 minus 1/2 t squared. So 1/2 t squared is equal to 8. T squared is then equal to 16. So t is equal to 4 seconds. And that's how we do problem number 4. Hopefully that helps.